What exactly is the area of a triangle? Imagine coloring in a triangle on a piece of paper. The area is the amount of space you color inside the triangle's lines. We measure this space in square units, like square inches or square centimeters. Knowing how to calculate triangle area is helpful in many areas like construction, design, and even baking. The most common way to calculate a triangle's area is with this simple formula. Area equals 1/2 times base times height. Let's break it down. The base is any side of the triangle. The height is the perpendicular distance from the base to the opposite corner, called the vertex. Remember, perpendicular means the height line forms a right angle, 90 degrees, with the base. We multiply the base and height, then take half of that product to find the area. What if we don't know the height of a triangle? This can be a common problem in geometry, especially when dealing with irregular shapes. Don't worry, Heron's formula comes to the rescue. This powerful formula allows us to find the area of a triangle without needing to know the height. This formula is particularly handy when we know the lengths of all three sides of the triangle. It opens up a new way to solve problems that might seem tricky at first. First, calculate the semi-perimeter, which is half the perimeter. The semi-perimeter, denoted as S, equals the sum of the side lengths A, B and C divided by 2, where A, B and C are the lengths of the sides of the triangle. This step is crucial as it sets the stage for the next part of the calculation. Then plug the values into Heron's formula. The area is found by taking the square root of S times S minus A times S minus B times S minus C. This formula might look intimidating at first glance, but it's pretty straightforward once you break it down step by step. With practice, it becomes a valuable tool in your math toolkit. Sometimes we know two sides of a triangle and the angle between them, the included angle. In these cases, we can use trigonometry to find the area. Here's the formula. Area equals 1/2 times B times C times sine of A. Here, B and C are the lengths of the two sides, and A is the included angle. The sin stands for the sine function, which you can easily calculate on most calculators. Remember, this formula works for any two sides and their included angle. Just make sure your calculator is set to degrees or radians, depending on how the angle is measured. Section 5, Practical Examples. Putting formulas to work. In this section, we will explore how to apply mathematical formulas to solve real-world problems. By understanding and practicing these examples, you'll gain confidence in using these formulas effectively. Let's see these formulas in action with some examples. We'll start with a simple yet fundamental shape in geometry, the triangle. Consider a triangle that has a base of 10 centimeters and a height of 6 centimeters. How do we find its area? The formula for the area of a triangle is straightforward. Area equals 1/2 times the base times the height. This formula is derived from the basic principles of geometry. So, substituting the given values, area equals 1/2 times 10 centimeters times 6 centimeters. Performing the multiplication, we get an area of 30 square centimeters. This method is quick and efficient for right-angled triangles. Now let's consider a more complex scenario. A triangle has sides of 5 centimeters, 7 centimeters, and 8 centimeters. How do we find its area when the height is not given? First, we need to calculate the semi-perimeter of the triangle. The semi-perimeter, denoted as S, is the sum of the sides divided by 2. So S equals the sum of 5, 7, and 8 centimeters divided by 2, which is 10 centimeters. With the semi-perimeter calculated, we can now apply Heron's formula to find the area. Heron's formula states that area equals the square root of S times the quantity S minus each side. So area equals the square root of 10 centimeters times the quantity 10 centimeters minus 5 centimeters times the quantity 10 centimeters minus 7 centimeters times the quantity 10 centimeters minus 8 centimeters. Simplifying this, we get the square root of 10 centimeters times 5 centimeters times 3 centimeters times 2 centimeters. So the area equals the square root of 300 square centimeters, which is approximately 17.32 square centimeters. This method is particularly useful for triangles where the height is not easily determined. Finally, let's look at a triangle with sides of 4 centimeters and 6 centimeters and an included angle of 30 degrees. How do we calculate its area using trigonometry? The formula for the area of a triangle using trigonometry is area equals 1/2 times the product of the two sides times the sine of the included angle. So area equals 1/2 times 4 centimeters times 6 centimeters times the sine of 30 degrees. Calculating this, we find that the area is 6 square centimeters. This method is very effective for non-right-angled triangles where an angle is known. As you can see, choosing the right formula based on the given information makes calculating the area of a triangle a breeze. Whether it's a simple right-angled triangle, a triangle with known sides, or one with an included angle, understanding these formulas allows you to tackle a variety of problems with ease and confidence. Section 6. Right triangles, a special case. Right triangles where one angle is 90 degrees deserve special mention. In a right triangle, the two sides that form the right angle are also its base and height. This makes calculating the area super easy. Simply use the basic formula. Area equals 1/2 times the base times the height, where the base and height are the lengths of the two legs of the right triangle. Section 7. Equilateral triangles, a formula for symmetry. Equilateral triangles have all sides equal and all angles equal to 60 degrees. They have a special formula for calculating their area. Area equals the square root of 3 divided by 4 times the side squared, where side is the length of any side of the equilateral triangle. This formula is derived from the basic formula and the fact that the height of an equilateral triangle can be calculated using the Pythagorean theorem. Section 8. Isosceles triangles handling two equal sides. Isosceles triangles have two sides of equal length. While you can use Heron's formula or trigonometric formulas to find their area, there's another formula specifically for isosceles triangles. Area equals 1/4 times the base times the square root of 4 times the square of one of the equal sides minus the square of the base, where b is the length of the base and a is the length of one of the equal sides. This formula simplifies the calculation when you know you're dealing with an isosceles triangle. Section 9. Practice makes perfect. Test your knowledge. This section is designed to challenge your understanding and reinforce what you've learned. Ready to put your newfound knowledge to the test? Let's dive into some practice problems that will help solidify your grasp on the concepts. Try these practice problems. 1. A triangle has a base of 12 meters and a height of 5 meters. What's its area? Remember, the formula for the area of a triangle is 1/2 the base times the height. 2. A triangle has sides of 6 inches, 8 inches and 10 inches. Find its area. Use Heron's formula for this one, which involves calculating the semi-perimeter first. 3. A triangle has sides of 3 feet and 5 feet, and the included angle is 60 degrees. Calculate its area. For this, you'll need to use the formula involving sine of the included angle. 4. A right triangle has legs of 9 centimeters and 12 centimeters. What's its area? Recall that the area of a right triangle is 1/2 the product of its legs. 5. An equilateral triangle has a side length of 4 millimeters. Find its area. Use the formula for the area of an equilateral triangle, which involves the square root of 3. 6. An isosceles triangle has a base of 10 centimeters and equal sides of 13 centimeters. Calculate its area. You might need to use the Pythagorean theorem to find the height first. Answers: 1. 30 square meters. 2. 24 square inches. Make sure to double check your calculations. 3. 7.79 square feet, approximately. 4. 54 square centimeters. Did you remember to use the correct formulas? 5. 6.93 square millimeters, approximately. 660 square centimeters. Great job. Keep practicing to master these concepts. Section 10. Conclusion: Mastering triangle area. Congratulations. You've now learned various methods to calculate the area of a triangle. From the basic formula to Heron's formula and trigonometric formulas, you have the tools to tackle any triangle area problem that comes your way. Remember to choose the most efficient method based on the given information. With practice, you'll be a triangle area master in no time.